In this video, we will discuss about maximum sum of distinct subarrays with length k. You are given an integer array nums and an integer k. Find the maximum subarray sum of all the subarrays of nums that meet the following conditions. The length of the subarray is k and all the elements of the subarray are distinct. Return the maximum subarray sum of all the subarrays that meet the conditions. If no subarray meets the conditions, return 0. So what they are saying is that in the input we are given an integer array nums and an integer k. We need to find out all the subarrays of length k from this array where no element is repeated. That means all the elements inside that subarray are distinct, right? And out of all these subarrays, whosever's elements sum is the maximum, that maximum sum has to be returned as our answer, right? So basically, length has to be k and elements have to be distinct within that subarray, and then you need to return the maximum sum, right? So see, one of the possible ways is that we find out all the subarrays of length k from this nums. Then within all those subarrays, we check what are all the ones where all the elements are distinct. Then out of those subarrays, we find out the sum of all of them, the sum of the elements of all of them, and then what is the maximum sum that we can return, right? So this is what we are going to do, but we will try to do it in less time, or we can say less time complexity, right? So see, we always want to consider a subarray of size k, right? Now this is given to us as 3. So this is one of the subarray, this is one of the subarray, this one of the subarray, then this and then this, right? So can you see again we have a sliding window. We have a sliding window which is moving towards the right one by one, right? And we are removing an element and we are adding an element. Earlier our subarray was this, then we considered this. So this element was removed and this element was added, right? So now whenever you are considering any subarray of length k, you need to have two things. The first thing is whether all the elements in that subarray are distinct or not. And the second thing is that you should know that what is the sum of all the elements in the current subarray, right? So see, how you will know whether the elements are distinct or not. You will have to store somewhere, right? You will have to mark the elements somewhere that, okay, this number has already appeared before, so I cannot take it again, right? So for that, we will use a map to mark whether that particular number has already appeared before or not, right? And sum we will calculate each time. Whenever we are moving our window, we will remove the first element and we will add the next element in the sum, right? And since it is a sliding window, we will have a starting index and an ending index as well, right? What we want is that we will take two variables, start and end. Both will be 0 initially, right? So I am indicating start and end with S and E, okay? So both will be here at the first index, right? So now you will see what is the current element. It is 1, right? Now let us suppose we have a map here. Let us suppose this is the map, right? Now this one right now is not present in the map. Then that means this one can be considered in our subarray, right? So what we will do is, so we will be taking a variable sum, right, which will initially be 0. This sum will denote us the sum of the current subarray, right? And then you can also take some answer variable for storing the maximum sum. We have kept it 0 because in case if there are no subarrays which are satisfying these conditions, then you need to return 0 as your answer. That is why this is 0, right? So now when you were at this element, you checked whether this one is present in the map or not. So you found out that it is not present, right? Then that means this element can be considered. So what are you going to do? You will do two things. That first you will mark this inside your map and you will add it in the sum, right? So corresponding to 1, we will store its index. Why we are storing its index? That I will tell you later. So our sum will now become 1, right? Now you can check that the length of the subarray is less than k, right? Then that means right now I cannot update my maximum sum. I will move forward. I will expand the window. So at each step, we are going to move our end one element forward, right? So now we will move our end here, right? So now this is the element 5. Now you need to check whether this 5 is present in the map or not. So you will check that, okay, this is not present in the map, so we can consider this. So one is that you will update it in the map, its index, and then you will add it in the sum. So sum will become 6 now. Again, the length of the subarray is 2, which is not equals to k. So you will move forward. And how are you calculating the length? With these two indexes. So your length will be end minus start plus 1, right? So now we are moving our end forward. So end will come here. Now you will check whether can we consider this 4 or not. So this is not present in the map, then that means we can consider this. So in the map, we will update 4 to 2 and the sum will now become 10, right? Now you will see that the length of the subarray has become equals to k. Then that means this is one of the possible subarrays. And what is its sum? It is 10, which is stored in sum. So now we can update our answer to the maximum of answer comma sum. So now answer will become 10, right? And again, we will move our end forward, right? Now when you will move your end forward, again you will check, can we consider this element or not, right? 2 is not in the map. So then that means 2 can be considered. Now when you have considered 2, you see that the size of the subarray has increased k. The size of the subarray has become 4 now. So we should try to shrink our window now. We should try to move the start towards the right so that we can reduce the length of the subarray to k, right? So what you will do is that you will keep on moving the start towards the right unless and until the length of the subarray is greater than k, right? So when you are here, the length is 4, so you will move your start forward. So when you will move start forward, when it will come here, this element we have removed, right? Since this element we have removed, we should also remove its contribution in the sum, right? So while you are decreasing the length of your subarray, you should also remove this from the sum or subtract it from the sum. So when you will move your start forward, it will be subtracted from the sum as well. So it will become 9, right? And now you will see that the length of the subarray is equals to k. So we can perform our normal operations, which is mark this 2 in the map. So it will be 3 and update the sum to add 2 as well. So it will become 9 plus 2, which is 11. Now you see the size of the subarray is equals to k. So we should update our answer. Answer is 10, sum is 11. So answer will be updated to 11, right? Now again we will move our end forward. So end will come here now. Now we will see whether can we consider this 9 or not. So this 9 is not present in the map. Then that means we can consider this. But now the size of our subarray is greater than k. So now we will try to move our start towards the right until our length is not equals to k, right? So you will move this start towards right. So this start will come here now and this 5 will be removed from the sum. So now sum will become 6, right? Now since we were considering this 9, then 9 should be updated in the map with its index and it should also be added in the sum. So sum is 15 now. And now you will see that the size of the subarray is equals to k. Then that means we should update our answer. Our answer is 11, sum is 15. So answer will be updated to 15, right? Then again you will move end forward. So now end will come here. Now you will see that this 9 is already repeated. How did you identify that? 9 was already present in the map with the index 4, right? Meaning the last occurrence of 9 was at index 4 and our start is present at index 2. Then that means 9 is already present within the current subarray that I am considering. Now you get it, right? Why we used index? Because see, let us suppose here 9 was not present but it was present at index 0. In that case, here 0 would be present, right? So through this 0, you can check whether this 9 is repeated within the current subarray or not, right? Because now in this case, 9 is appearing only once. And how did you identify that? Because the last index of 9 was 0 and start is present at 2. Then that means although 9 was present earlier in the array, but it is not present in the current subarray that I am considering, right? That is why we are keeping the indexes here. But in this case, the index of 9 is greater than start, then that means it is present in the current subarray. So we won't consider it. we won't consider this subarray. So now what are we going to do? We are going to shift our start towards the right until we have distinct elements in our subarray, right? So basically you will move your start to the index of 9, last index of 9 plus 1, because when your start would be present at 5, only then we can say that the repeated 9 has been removed from the subarray, right? So now here we could simply update our start to this index plus 1, but we cannot do that because when we are moving our start forward, we also need to subtract all the elements from our sum which we are removing from the subarray, right? So we will have to move start one by one towards the right until this particular index is present in my subarray, right? And I'll keep on deducting that number from the sum. So right now you are at 4. So we will deduct 4 from the sum. So it will become 11 now. Then your start will come here. Now the number is 2. So you will deduct 2 from the sum. So it will become 9. Then again you will move your start forward. So it will come at 9. So you will subtract 9 from the sum. So your sum will become 0. Then again you will move your start forward. So start will come here. Now at this point, your start has become greater than this index. So now we can say that we have removed that repeated element from our subarray, right? So now we will again start the same process. Now you check. You can consider this 9, right? We can consider this because its last index is 4 and we are at index 5. The start is at index 5. So we will consider this 9 now. So our sum will become 9. It will be updated in the map. The new index will be 5. Now you will see that the length of the subarray is not equals to k. So we should not update our answer. We should move forward. So now your end will come here. Now this is the subarray. Now here 9 again you will see that it is already present at index 5 and start is also present at index 5. Then that means within the current subarray this particular number is repeated. So we should move our start forward. So you will move your start forward. So start will come here and 9 will be deducted from the sum. So sum will become 0. Now the start, that is 6, is now greater than 5. So we can stop, right? Now since we are considering this 9, so it will be updated in the map. It will be added in the sum and you will see that the size of the subarray is not equals to k. So answer won't be updated. So we will move our end forward now. So end will come here. But now we have exhausted our array. So we will stop. And whatever is present in our answer, which is 15, that is going to be our answer, right? So basically what we are doing is that we are keeping our start and end on the first index initially. We are keeping a sum 0 and an answer 0 initially, and we have taken a map. Then we are iterating inside nums until the end reaches the end of the nums array, right? And then we are checking that whether the current element, what will be the current element? It will be nums of end, right? So we'll check whether this particular element was already present in the map or not, right? If it is already present and it is present within the subarray that we are considering, then we will start moving our start forward until the last occurrence of that particular element which we have gotten from the map. Until that is lying within the current subarray, I will keep on moving my start forward. So basically this start is moving forward in two cases. First, when the element is repeated, and second, when the length of the subarray has increased k, right? In these two cases we are moving our start forward, right? And once we have removed all the duplicate elements from our subarray and we have reduced the size of subarray, we will update the occurrence of the current character in the map and we will also update our sum. Then we will check that what is the size of the current subarray. If it is equals to 3 or k, then we will update our answer as well. And in each iteration, we are moving our end forward. So this is the simple approach that we are following. Let's quickly code this out. So first of all, we will take two variables, start and end, right, which will denote the starting and ending index of our sliding window, and we will store the size of nums in n, right? Then we need two variables for the sum and answer, so that has to be long. So long sum equals to 0, answer equals to 0, right? Then we will create a map for marking the occurrence of the numbers, right? Now we are going to iterate while our end is less than n, right? Now inside this, what is the current number? The current number is nums of end, right? Now you need to find out what is the last occurrence of this number from the map, right? So initially we will keep its value as -1. and then we will check whether it is present or not. So in the map, we will find whether cur is present or not, right? So if mp dot find cur not equals to mp dot end, then that means the current element is already present in the map. So the last occurrence will be equals to this, right? So if the current element was not present in the map, then your last would be equals to -1, right? So now we should check. Now we should check that whether the current element was already present or not. If it is already present, then we have to move our start forward. And moving start forward also had another condition, that if the size of the subarray is too big, then also we need to move our start forward, right? So what we will do is, we will check that while our start is less than equals to last, right? Or end minus start plus 1 is greater than k. So the first condition is used for removing the repeated element, and the second condition is used for when the size of the subarray has become greater than k. So until any of these conditions are true, from the sum we will remove the starting element and we will move our start forward, right? And once we have moved our start forward to a valid index, we will update the current element in the map and in the sum. So at cur in MP, we will update it to the end, which is the index of current element. And in the sum, we will add the current element, right? Now we need to check that if the size of the subarray has become equals to k, then I should update my answer as well. So answer will be equals to maximum of answer comma sum, right? And at each iteration, we need to increment our end by 1, right? And at the end, we can return our answer. Simple. So let's quickly run this. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.